All right, so looking at our last set here, two-sample t-interval t-test for population mean. So very similar to the processes that we've done before. So a couple examples here. So again, this is when we're collecting quantitative data. We want to look for the difference in population mean. So some examples, comparing average number of chocolate chip cookies between two brands, seeing if music improves your score in a memory quiz, which one of the examples we're going to take a look at today. And there's a couple others there. That double stuffed Oreo one is interesting. Another group that did that last year and was actually pretty good. They took it a step further, and what is it really worth the price difference? So there's some interesting things that you can do with that information. So we look at our example. So we want to investigate if listening to music makes a difference in taking a memory quiz. And so we set up an experiment with 30 volunteers. We randomly assign. That's important. We'll talk some about that with your own project. We got to have random sampling or random assignment somewhere in there. So 15 go to music listening group and 15 go to the non-music group. Get the same memory quiz and record the scores, and we get the following information. So first thing we need to do, just as we've done with every single problem, is we need to come up with our parameter. What is it that we exactly want to look at and try to test? Here it's a two sample, and so we're going to have mu 1 minus mu 2. And what that's going to tell us is the true difference in mean memory scores, or in mean scores on the memory quiz, between our two groups, music, which is our mu 1, and non-music, which is mu 2. All right, so there's our parameter. Then next, we want to state our estimation. So we're going to estimate at 90% confidence, and the reason 90% is our sample is not very big, and so generally you go for a smaller confidence level with that. Then we pull in our statistics, which are all listed up here. So our sample mean, so our x hat 1 is 14.4, our standard deviation 1 is 3.5, and our N1 is 15. Then our mean of 2, our x hat 2 is 12.1, our standard deviation 2 is 3.1, and our N is 15 on this as well. You would have raw data that you put in, and you go to Staplet and you calculate all of this. We did that for you, but we're still going to go to Staplet, and what we're looking for is this going to be a two sample t-interval, and where we find that is under one quantitative variable but multiple groups. All right, so let's jump over there. All right, so one quantitative variable, multiple groups this time. We'll call that quiz. And then our two groups, sorry, we don't want raw data. You would put in raw data. We have mean and standard deviation. Our two groups are music and non-music. Our mean, again, is 14.4. Standard deviation was 3.5, and our n is 15. And then our second mean was 12.1, standard deviation 3.1, and n is 15, and that one as well. Begin analysis. Your raw data, you would have a chart that would pop up. Since we don't have raw data, we don't have that, so we're going to go down form inference. There you can see we have 2 sample t-interval, 2 sample t-test. We wanted the interval this time. Degrees of freedom, leave that as no, that doesn't matter. Change our confidence to 90, and we perform our inference. We get our lower and upper bound there. So we go ahead and copy that over. Oh, that's why. Sorry, let me edit the inputs here. This should be 12.1. Just confused there for a second. There we go, that looks better. All right, so our interval was from 0.245 to 4.355. All right, from that we get a margin of error of 2.3 when we find the actual difference between our values, and then plus or minus 2.055. Okay. And then we want to interpret that. And so what we're going to state is we are 90% confident that music listeners score between 0.245 and 4.355 points better than non-music listeners on the memory quiz. Okay, and so when we first did this with proportions, I showed you 2 of them of like the generic, hey, we see this difference, but in light of both of these being positive, it shows that our mu1, all right, which is our music listeners, performed better in both cases on the low end and the high end. And so putting it in this light explains that better, which then leads to better conclusions and when you draw out your final results and the implications for that. Okay. Then we'd continue on to a t-test. So looking at this in terms of how this would flow for you on your project, you'd go from interval to t-test. So the thing we've been doing next would be our parameter. We already have that from above, so we don't need to write that again. We're just kind of flowing through here, but we do need to start with our null, hypothesis, and alternative, because in order to test something, you need a hypothesis to test against. Our null hypothesis is going to be mu1 minus mu2 equals 0. This is telling us that there is no difference between the 2 groups. So music listeners, non-music listeners, essentially there is no difference in how well they do on the memory quiz. And that's kind of what is to be expected. And that's what the null hypothesis is. And then our alternative hypothesis is what you're hoping to prove. In this case, generally you put your mu1 as the one that you think is going to be better. So in that case, we're going to state that mu1 minus mu2, our difference in means is going to be greater than 0. And what this is stating is that music listeners will score higher. All right, essentially stating that mu1 is greater than mu2. All right, and then we take our data. Again, it's nice to just have it down here as a reference as you're looking at it. And the other thing we'll do here officially is we'll find our difference. So x1, so our sample mean 1 minus our sample mean 2 is the 14.4 minus 12.1, which we already found, but that gives us that 2.3 there in that difference. And then what we want to do from here is now we're going to go Staplet. We're already in Staplet, but now we're going to look for the t-test. Okay, so we'll hop back over here. Nice thing is we don't have to retype anything in. We just have our inference difference. There's our 2-sample t-test. Okay, degrees of freedom leave as no. Alternative hypothesis, double check. We want a greater than 0, which is the default one. So we can go ahead and perform our inference, and we get our t-value and p-value there. We don't worry about the df, degrees of freedom. So let's bring that over here. So t equals 1.905. The p-value equals 0.034. Look at this on our distribution. All right, so there's a difference of 0. We got a difference of 2.3, and we want a greater than, so we're looking at what that shaded area is there. This p-value then is that there, which as a percentage is 3.4%. And what that tells us is a bunch of different things. So if we ran a bunch of simulated trials, 3.4% of the data would be found in that shaded area. The probability of getting a difference of 2.3 again is at 3.4%, which then implies that the probability of our null hypothesis being true is at 2.3, or sorry, our null hypothesis being true is at 3.4%. Okay, and so based on that, we can do our interpretation, okay, that since 3.4% is less than our cutoff of 5%, we reject our null hypothesis and have convincing evidence that music listeners perform better or have higher scores than non-music listeners on a memory quiz. All right, any of the two practice problems down below.